Hello everyone, I am Mukund Srinath and this is the presentation for PrivaSeer, a privacy policy search engine. The people who worked on this are myself, Soundarya Sundareshwara, Lee Giles, and Shamir Wilson. We are researchers from the Pennsylvania State University. In this presentation, I'm going to talk about what is a privacy policy search engine, how we collected the data to build the search engine, the various decisions that went into making the search engine, such as indexing, ranking, filtering, evaluation, and finally, the conclusion. First, what is a privacy policy? A privacy policy is a legal document that an organization uses to disclose how it collects, uses, shares, and secures its customers' personal data. Various laws around the world, such as GDPR in the European Union and CCPA in the United States, make it mandatory for organizations to make their privacy policies available to users. The idea behind these laws is that users are going to read the privacy policies offered by organizations, and then they're going to make decisions about whether they want to use the services offered by the organization based on the privacy practices of that organization. But in reality, things don't work this way because most internet users do not read privacy policies. Various NLP techniques have been applied in order to simplify privacy policies, but these NLP techniques face issues of scalability and generalization. The motivation for PrivaSeer is based on two factors. First, it is difficult to collect privacy policies. This lack of corpora available impedes privacy research. Second, there is a lack of automated tools which can be used by policy enforcers in order to regulate privacy policies online. So we built PrivaSeer, the first of its kind privacy policy search engine that can be used to search and filter from over 1.4 million website privacy policies. PrivaSeer will help privacy researchers to collect privacy policies and filter them based on their requirements. PrivaSeer will help policy regulators to find anomalous privacy policies online. Next, let's talk about how we collected the data to make PrivaSeer. The privacy policy search engine was made from PrivaSeer corpus, which has 1.4 million website privacy policies. The PrivaSeer corpus was collected starting from two data sources. First, Common Crawl, and second, the Free Company dataset. Common Crawl is an organization which crawls the web and releases these web crawls for free online. The Free Company dataset is a dataset of URLs of companies found on LinkedIn. To collect privacy policies from these two data sources, we came up with a crawling pipeline. We noticed that privacy policy URLs tended to have the words privacy or the words data and protection in them. So we created this URL selection criteria and extracted all of the URLs from the common crawl dataset and the free company dataset. We crawled the URLs extracted from the common crawl dataset in July 2019, and we crawled the URLs extracted from the pre-company dataset in February 2020. The crawling pipeline consists of multiple stages. We recognize that when we downloaded all of these URLs, they might have different languages, they might not be privacy policies, and they might have other issues too. So our crawling pipeline takes care of these issues. The first stage of our crawling pipeline was a language detection step, which filters out all of the web pages which are not in the English language. Second, we have the document classification step, which separates privacy policies from non-privacy policy documents. Then we have the duplicate and near duplicate detection step, which separates duplicate web pages or web pages which are very, very similar to each other and from the same domain. And finally, we have the boilerplate removal step, which removes all of the content on the web page which isn't the privacy policy itself. Next, let's talk about the indexing. We created two indexes, one with and one without non-policy content. Non-policy content can also be called boilerplate. And the reason we created two indexes was that we wanted to see if the extra information on the page from, for example, the header, the footer, or the navigation menu can contribute in some way to the quality of the search. We use Elasticsearch to create an inverted index with the title, body, and the URL. The body and the title were tokenized based on a grammar-based approach. The URL was tokenized using a regex tokenizer based on an alphanumeric character approach. Next, let's talk about ranking. We created a custom ranking function which can be used by users to rank the policies from PrivaSeer. The custom ranking function is based on three factors: the query-based document relevance, the probability of the document being an actual privacy policy, and the page rank of the URLs of the privacy policy. At the bottom of the slide, you can see the formula for calculating the ranking score for each document. The relevance was based on the BM25 algorithm. The page rank was calculated using the Gauss-Seidel algorithm from the web graph released by Common Crawl. And we used a random forest classifier to calculate the probability of the document being a privacy policy. Here you can see the technique we used to calculate document probability. We labeled 1,000 documents that we crawled as being either a privacy policy or not a privacy policy. And 100 of those documents were used for validation, while the rest was split into train and test sets in the ratio 4:1. We use document term frequency, inverse document frequency features to train the random forest classifier. And after a five-fold cross-validation, we obtained a precision of 0.96 and a recall of 0.97. On the right of the slide, you can see a histogram of the probabilities of the documents being a privacy policy. In the x-axis, you can see the probability, and in the y-axis, you can see the number of privacy policies in that probability range. You can see from the figure that most of the privacy policies in PrivaSeer have a high confidence of actually being a privacy policy. Only a very few documents have a probability range between 0.5 and 0.8. Next, let's talk about filtering. We made filter facets available to users based on six different factors. Firstly, sector of commerce; second, readability; tracking technology; self-regulatory bodies, regulations and agreements; and finally, vague language. Let's look at each of them separately. First, sectors of commerce. The free company dataset had 148 unique industries, and we consolidated them into 11 sectors of commerce. Sector of commerce information can be very important to privacy researchers and policy regulators. Privacy researchers might want to collect privacy documents only from certain sectors of commerce, and policy regulators can use the sector of commerce facet in order to find anomalies within sectors of commerce. The figure on the bottom of the slide shows the distribution of the different sectors of commerce. You can see that the maximum number of documents are from the unknown sector. This is because we had industry information only for the documents that came from the free company dataset, while we did not have information for those that came from the common crawl dataset. Next, let's look at the facet tracking technology. Tracking technologies are very commonly mentioned in privacy policies, and so we extracted common mentions of tracking technology using regex queries. The table here shows the 6 most common types of tracking technology mentioned in privacy policies and their distribution in the PrivaSeer corpus. Here you can see that the tracking technology cookie appears in almost all of the privacy policies at around 84.2%. Next, let's look at the facet self-regulatory bodies. Some jurisdictions rely on organizations to self-certify their privacy compliance. These organizations work with self-regulatory bodies to provide them with privacy seals and certificates. Next, let's look at the facet regulations and agreements. While some jurisdictions rely on self-regulatory bodies, others rely on concrete regulations and compliance agreements. We extracted the mentions of the 8 most common regulations and cross-border agreements. On the right, you can see a table of the 8 most common regulations and cross-border agreements and their distribution. You can see that GDPR, or General Data Protection Regulation, from the European Union is the most commonly occurring regulation or cross-border agreement. Next, let's look at the facet vague language. A term is regarded as vague if it admits borderline cases where the speaker is reluctant to say either the term definitely applies or definitely does not apply. We find that vagueness limits readers' ability to precisely interpret the contents of privacy policy. We used the corpus created by Lebanov and Liu to automatically classify sentence vagueness of privacy policies using 40 keywords for vagueness. We modified the corpus to remove annotations when they were annotated as vague due to co-reference issues. Consider the sentence, you will find more information about this in our cookie policy. In this sentence, the word this is a co-reference, but in the corpus created by Lebanov and Liu, that word was annotated as vague. Lebanov and Liu created their corpus by considering each sentence separately. So when an annotator looked at the word this in a sentence without any context, that word appeared as vague. But because we wanted to calculate the vagueness of the whole document, we removed annotations on these words, which were co-references, when they appeared as vague. In order to train a vagueness model, we used a technique similar to Lebanov and Liu. We fine-tuned Roberta, a pre-trained language model, on an entity recognition task to pick vague words in a sentence. We extracted sentences from all of the policies when they had any of the 40 keywords of vagueness and fed them through the model. On the right, you can see the results obtained by Lebanov and Liu compared to the results that we obtained. Although the results obtained by Lebanov and Liu are slightly better, we believe that this is because their corpus contained co-references while ours did not. On the bottom of the slide, you can see a figure of the distribution of vague sentences in the PrivaSeer corpus. The red indicates all the sentences that the Roberta model found as vague, while the blue indicates all of those sentences that are candidate vague sentences, that is, those sentences extract from the PrivaSeer corpus which had any of the 40 keywords of vagueness. The figure itself is a histogram where the x-axis is a ratio of vague sentences to the total number of sentences. So it starts with 0 and has a maximum value of 1, while the y-axis is the number of privacy policies which has that ratio of vague sentences. You can see that a mean of about 50% of the sentences in a privacy policy is a candidate vague sentence, while only about 30% is actually classified as vague by our model. Next, let's look at the demo for PrivaSeer. This is the PrivaSeer landing page, and users are presented with a simple text box on the landing page. Users can search for any word, either in the policy text itself or search from the policy URL. For example, I will search for the word address. Address is a very common personal information type. When I hit search, it takes me to the results page. The results page first displays the number of hits for that particular search term or query term, and it also has the results for that query. Each result has the page title, the page URL, its industry, the date it was crawled, and a small text snippet which contains the query word. On the left and right of the results page are the various search facets. Here you can see the search facet industry, tracking technology, self-regulatory bodies, and regulatory agreements. While on the right, you can see that users can sort the results by various sorting techniques and can also filter based on readability and policy vagueness. When a user selects any of these search facets, for example, I'm going to select the facet education, the number of results decreases. You can see that the results decrease from about 1.25 million to about 27,900. This is because only those results which fall in the industry, education can now be found in the search results. Users can further filter them based on the other types of tracking, other types of facets. For example, if I select the facet cookies, only those results which have the tracking technology cookie mentioned and which fall in the sector of commerce, education appears in the results. The user can also sort based on various ranking techniques. By default, the ranking technique is the custom ranking technique. The users can also use simply the query similarity or the page rank, or can even sort based on readability of the document. Similarly, users can filter results based on the readability level. Here, the readability is measured by the Flesch-Kincaid reading level. The Flesch-Kincaid reading level is the number of years of US education required to understand a piece of text. And finally, the user can filter based off of vagueness. Here, a vagueness value between 0 and 1 can be input. For example, if the user inputs 0 and 0.25 and hits submit, the results are further filtered, and here you can see that the number of results is about 8,000, which is and has only those results which have at least, or sorry, at most 25% vague sentences. Getting back to the presentation, next let's look at the evaluation. We evaluated PrivaSeer based on 2 indexes, 3 query themes, and 3 ranking functions using precision at K scores. Precision at K measures the number of relevant results in the top K returned results. Here you can also see the 3 different query themes that we used. 3 query themes we used are personal information type, security, and privacy practice type. These are the 3 types of query themes that we expect users to perform in PrivaSeer. The table also shows the different queries we use for evaluation in each of the query types or query themes. Here you can see the results based on the 3 different ranking techniques, the 2 indexes, where one of them contains non-policy content and one of them does not have non-policy content. The results displayed are for precision at 5 and precision at 10 values, and PI, SS, and PP stand for the 3 different types of query themes. You can see that the custom ranking function has the best performance overall, irrespective of the query themes or of the indexes. We found that the document probability scores improved the ranking significantly. We believe that this is because including the document probability scores in the custom ranking function helped suppress those results from very high page rank values, which also had the query term. So it helped suppress false positive results. Second, we found that non-policy content from the header and footer deteriorated ranking scores from all 3 categories. We found that the custom ranking function has a higher variability of results when compared to the other ranking techniques. This is true because whenever PageRank is included in the ranking function, most of the top results are those which have a very high PageRank value. This problem is compounded by the fact that privacy policies from high PageRank domains tend to be longer, and so they tend to incorporate all the different types of queries that were included in our examples. Finally, in conclusion, PrivaSeer is the first privacy policy search engine and has about 1.4 million privacy policies. Documents can be ranked based on query similarity, page rank, and the probability that the document is a privacy policy. Documents can be filtered based on sector of commerce, vagueness, readability, and mentions of tracking technology, regulatory bodies, and regulations and agreements. PrivaSeer will help several groups of users gather privacy policies. Future work could concentrate on adding a temporal component to the collection of privacy policies or explore an alternative ranking method. Here are the references for this presentation. Thank you.